Eve is an experienced engineer. She gets all of her tasks done on time. She is very reliable. But in order to advance in her career path, she has got to do something new. She has got to start challenging herself outside of her comfort zone. Adam's a fun guy. We all love Adam. He's always good for a laugh or for a chat. He doesn't get his work done, but he's never broken production because he doesn't do any work. We make excuses for him. We say he doesn't do any harm. At least he isn't toxic. As managers, we have certain concepts and paradigms that we have repeated so often, we treat them as if they are set in stone. Let's take a look at something very common that surrounds us at concrete and see how we can challenge these paradigms. Whenever we see an amazing concrete structure, we always say to ourselves, wow, concrete is so strong. Concrete is indeed very strong. It can withstand incredible compression loads. Sadly enough, standard concrete can only support a tensile load of about 1/10 of the compression load it can bear. We can squash the concrete, but we can't stretch it. It will crumble. Let's revisit Eve's situation. If we have got an engineer who is extremely good at what she does, and we insist on challenging her outside of her comfort zone, it might only yield 1/10 of the benefit. If we look at a concrete beam leaning on columns, the concrete now sags down in the middle. The top fibers are being squashed. They have a compression load which it can bear. The bottom fibers are being stretched. Tensile loads develop. The concrete can't support this load. That's why sometimes when we drive under a bridge, we see the beams are in the shape of these like ribs, in the shape of a capital I or a capital T. The fibers below the fold are only used to support the steel rods that reinforce the concrete. Instead of having a simple oblong cross-section, the engineer plans the concrete either in the shape of an I or a T. There is concrete on the top to support the compression loads, and concrete on the bottom to support the steel rods. The red sections have been removed. They only add additional weight. They do not support the concrete beam. The same as Adam. If he isn't doing his job, he is hindering the team. You either support the team or you are an additional weight that the team has got to bear. We all know these soloists. The engineers don't cooperate, don't communicate, they don't work so well in a team, but we make excuses. We say, they are stars. Let's accept their unpleasant behavior. Why do we use steel to reinforce concrete? Steel is very strong, but steel and concrete have got the same thermal coefficient. They both contract and expand the same way in reaction to temperature changes. If our team works well together, they can support a heavy load. If our team doesn't work well together, we get an exploded tin of Coke in the freezer. Do not underestimate the value of teamwork. Based on a true story, it happened to me, an exploded tin of Coke in the freezer. Usually we love our technological solutions. We have always done it this way. Someone comes and suggests a change. We say, no, that won't work. We see no reason to change what we have done. We mix cement and water, we pour the wet concrete, and while it dries, it develops its strength. One of the key requirements of helping concrete develop its strength while it dries is to cure the concrete. Do you know what curing the concrete actually means? How do we cure the concrete? Curing the concrete actually means watering the concrete. As impossible as it sounds, one of the key requirements of helping concrete develop its strength while it's drying is to water it. Don't discard an idea just because it sounds impossible. Work-life balance, the holy grail. We all want to maintain a healthy work-life balance. We all want our engineers to maintain a healthy work-life balance so they come to work energized and motivated. But sometimes we have unusual structures that have got to bear an unusual load, like a bridge for a train, and then we can't use regular reinforced concrete. We have got to use pre-stressed concrete. Pre-stressed concrete is concrete that after we pour the concrete, we insert steel rods, we pull them, and then the resting state of the beam actually bears a large compression load. Once we lift the beam, the bottom fibers, instead of being stretched, instead of bearing a tensile load, are now in equilibrium. But the problem is that pre-stressed concrete is much more expensive than regular concrete. The same as our engineers, for unusual projects, we can break this balance, but we must be aware that it comes with a cost and only do it for unusual projects. Thank you.